Let's look at the algebra of functions. With the algebra of functions, we can have the sum of two functions, written f plus g of x, and that's equal to f of x plus g of x. The difference of two functions, f minus g of x, is f of x minus g of x. The product of two functions, f times g of x, means to take the f of x function and multiply it times the g of x function, and the quotient of two functions, f divided by g of x, equals f of x over g of x. The notation here is going to be new, but combining the functions you've actually done in earlier algebra classes. I want you to remember when you have the difference of two quotients to distribute the negative. That's one of the most common mistakes. You're going to make sure that you distribute that across the g of x function. With the quotient of two functions, since g of x is in the denominator of the fraction, you'll also need to remember that g of x is not going to be allowed to equal 0. Let's look at some examples of this. If we have f of x equaling 2x plus 1 and g of x equaling 3x plus 2, if we're asked to do f plus g of x, that's just our new notation for take the f of x function and add the g of x function to it. At this point, we just substitute f of x is 2x plus 1, g of x is going to be 3x plus 2, and we're just combining the like terms. 2x and 3x make 5 of our x's, positive 1 and positive 2 make a positive 3. So f plus g of x is just equal to 5x plus 3. If we're going to look at f minus g of x, that's the fancy notation for take the f of x function and subtract the g of x function. Or in this case, take the 2x plus 1 and subtract the 3x plus 2. Notice that when I'm substituting, I'm putting these functions in parentheses. Hopefully that's going to remind you that you have to distribute the negative on the subtraction. First parentheses of 2x plus 1 stays the same. We're going to subtract the 3x, and then we're also going to subtract the 2. To combine like terms, 2x minus 3x is a negative x, a positive 1, and a negative 2 is just a minus 1. Combining these functions using the product is going to be f times g of x, which is just the notation for take your f of x function and multiply it times your g of x function. Or in this case, take the 2x plus 1 and multiply it times the 3x plus 2. This is just a distributive property, or a FOIL. First terms, 2x times 3x is 6x squared. Outer terms, 2x times positive 2 is a positive 4x. Inner terms, 1 times 3x is a positive 3x. And last terms, 1 times 2 is going to be a positive 2. Combining your like terms for a final answer of 6x squared plus 7x plus 2. The quotient of these two functions, f divided by g of x, means take the f of x function, put it on the top, take the g of x function, put it on the bottom. So the 2x plus 1 is going to go on the top, and the 3x plus 2 is going to go on the bottom. Since we have a fraction, we're going to note the domain. The 3x plus 2 is not going to be allowed to equal 0. After I subtract 2 from both sides, 3x is not going to be allowed to equal a negative 2. So x is not going to be allowed to equal a negative 2/3 in this problem. If we looked at the domain of all of these functions, f of x starting off would be all real numbers because there's no fractions, no even-indexed radicals, and so would g of x. Because there's no fractions or even-indexed radicals, we can use all real numbers in both of those functions. So when we add them together, our domain is still going to be all real numbers. When we subtract them, it will be all real numbers. When we multiply them, we can use all real numbers. But when we divide them, we're not going to be able to use the value of x equals negative 2/3. So we're looking at from negative infinity to negative 2/3, not including the negative 2/3, combined with starting at negative 2/3 and going to positive infinity. Let's look at one more example. Let's look at the function f of x equals the square root of x plus 2 and g of x equals x minus 7. If you look at f of x being the square root of x plus 2 and state your domain, because we have an even indexed radical, the x plus 2 has to be greater than or equal to 0. Therefore, if I subtract 2 from both sides, our domain is going to be x has to be greater than or equal to negative 2. On our g of x, our domain, because we don't have any fractions or even indexed radicals, will be all real numbers. So let's look at the algebra of these functions, combining them together. F plus g of x means take our f of x function and add our g of x function to it, or take the square root of x plus 2 and add it to the polynomial of x minus 7. In this case, we cannot combine any like terms. We just have the square root of x plus 2 plus x minus 7. Our domain, because we have the even indexed radical, is still going to be x has got to be greater than or equal to negative 2, or starting at negative 2 and going to infinity. If we look at the subtraction of these two functions, we'll have f of x minus our g of x. Substituting in, we have the square root of x plus 2 minus the x minus 7. Remember, we need to distribute on this one, so we still have the square root of x plus 2 minus our x plus our 7. Again, we can't combine any like terms, but because we have that radical, our domain, like we solved before, is still going to be starting at negative 2, including the negative 2, and going to positive infinity. When we look at the product of these two functions, we'll have f of x times g of x, or in this case, we're going to take the square root of x plus 2 and multiply it times the x minus 7. We are going to have to remember the distributive property. The square root times the first term is going to give me x times the square root of x plus 2. And then the square root times the second term is going to give me a minus 7 times that square root of x plus 2. Again, looking at the domain, because we have those even indexed radicals, we solved for that earlier, those exact same radicals. The domain has to start at negative 2 and go to positive infinity. When we look at f divided by g of x, and we put the f of x on top and the g of x on bottom, after substitution, we're going to see that we have the square root of x plus 2 on the top, and we have the x minus 7 on the bottom. Domain's going to get a little trickier on this one because we have both exceptions. We have an even indexed radical and we have a fraction. We know because we have that even indexed radical, we've already said that for that particular radical, x has to be greater than or equal to a negative 2. Because we have the fraction, the bottom of the fraction is not going to be allowed to equal 0. When we solve that and add 7 to both sides, we'll see that x cannot equal a positive 7. Now, if we put both of these domains on a number line, x has to be greater than or equal to negative 2, will look like this, and x cannot equal a positive 7 would be every real number except for that positive 7. The final domain is going to be where are both of these both true, and you'll notice in this section right here they're both true, and in this section right here they're both true. So your final domain is going to start with your x being a negative 2, go to the positive 7, but not include the positive 7, and start up again with the positive 7, not including it, going to positive infinity.